Lesson 21, solving one-step equations by multiplying and or dividing. Now, previously we've learned about solving one-step equations with addition or subtraction, and in our lesson we learned that in order to do so, you have to use a property of equality, the addition or subtraction property of equality, which say if you add something to one side of the equation, you add the same thing to the other side of the equation, it actually has equal, the equation is still equal. So you add or subtract to one side, it's still an equal equation. And this is one way that we use this property, the property of equality, to get rid of something that's on one side of the equation or to simplify the equation to find out what that variable is by itself. Today we're going to take that learning to the next level and apply it to multiplying and dividing. Here in our new concepts section it says, to find the solution of an equation, we want to isolate the variable by using inverse operations. That means in any equation in which you have a number and a variable next to each other, you want to separate that number and variable. We want the variable to be all by itself, and we want the number to be eliminated. Well, one way to eliminate that number or to move that number around is to use the inverse operation, whether it be addition or subtraction, or in this case, multiplication or division. You must use the same inverse operation on each side of the equation. So when you see an operation in an equation and you want to get rid of that number, you do the opposite operation. Here's the example, multiplication property of equality. Both sides of the equation can be multiplied by the same number and the statement will still be true. For example, if 2 equals 2 and 3 times 2 equals 6, then 3 times 2 equals 6. You multiply by the same thing on both sides and you got the same exact answer. How that's written out in a more technical term with variables is that if A equals B and A is multiplied by C and B is multiplied by C, then both those sides of the equation are also equal. So anytime that there is multiplication that's happening on both sides, the equation is still equal, just like in the form of the division property of equality. If you divide by the same thing on both sides of the equation, you get the same answer. Both sides of the equation can be divided by the same number and the statement will still be true. For example, 10 equals 10, 10 divided by 2 equals 5, it's the same thing as 10 divided by 2. So if A and B are equal to each other, if they're both divided by C, they're going to be equal. But in this case, the only way it doesn't work is if C is equal to 0, because you can't have 0 in your denominator in that case. So we use inverse operations, and when we use inverse operations, what we do to one side, we do to the other side. That's why this makes this a property of equality. Therefore, you're going to balance out that equation, and a lot of times use that to simplify the equation. In the video you watched, it went through inverse operations to complete this table between these items. In example 1, it's asking you to solve equations by multiplying. In each one of these examples, you're going to see that there's a fraction bar, a fraction, a fraction, a fraction, and when you see that fraction, that actually means division, so you're doing the opposite of that. You're looking here what's in the denominator and then multiplying by that value. So here, for example, it's x divided by 6. You multiply by 6 because that will cancel the 6's. You'd have x all by itself. That's what we want. When you multiply by 6 on this side, you have to multiply by 6 on this side. Therefore, simplifying 8 times 6 and then x to get your answer. 8 times 6 equals 48. In example 2, you're solving by dividing. Here you see multiplication, but you think, what is the inverse or opposite operation? So you go ahead and take on that division. 5 times x is what this says. What's the opposite of 5 times? Well, it'd be divided by 5. 5 divided by 5 cancels out. That would equal 1. 20 divided by 5, what you do to one side, you do to the other. 20 divided by 5 is then 4. Anytime that you see multiplication, here for example, negative 12 equals 3 times n. 3 times n is our multiplication. The inverse of multiplication is division, so I would divide 3 on both sides. Divide by 3, divide by 3. That's what they do here, division property of equality. And then they're going to get n by itself, simplified, and then 12 divided by 3 is negative 4. In our application, it talks about and uses a word problem to set up a formula, and then you have to solve for what you don't know in that formula using the properties of equality and solving for that missing variable. Let's take a look at our lesson practice problems because they are going to show us how in which we can master this skill of using the division property of equality and multiplication property of equality to solve. These are called one-step equations. You're using one operation to get that variable all by itself. Let's take a look. In our practice problems today for lesson 21, remember our skill is using the division property of equality or the multiplication property of equality. We look at the equation, we see what operation is being used, and then we think, what is the opposite operation? So I'm going to use the inverse operation to try and get that variable all by itself. When I use that inverse operation, I need to think that what I do to one side, I do to both sides. That should help me to isolate that variable and simplify that expression. Take a look at letter A. We've got k divided by 9. If it says divided by 9, I know I need to do the opposite of that. So we're going to multiply by 9. Those two things would cancel. If I multiply by 9 on one side of the equation, I multiply by 9 on the other side of the equation, I get 3 times 9. 3 times 9 is 27. What's left over here was k all by itself. K equals 27. In letter B, I've got negative 20 equals 1/5 times m. 1/5 times m. Now, the opposite of timesing by 1/5 would be dividing by 1/5. But there's a special rule when it comes to a fraction that's involved. Instead of multiplying by a fraction, I can actually multiply by the reciprocal. So instead of multiplying by 1/5 to eliminate this, I can actually multiply by 5/1. Instead of dividing by a fraction, I can multiply by the reciprocal. So 1/5 times 5 is actually going to cancel these out, so m is all by itself. If I multiply by 5 on this side, I multiply by 5 on the other side. 5 times 20 is going to be 100. It's negative, so it remains negative, negative 100. Letter C, 8y, 8 times y equals 24. 8 times y is our operation. The opposite of times 8 is divide by 8. What I do to one side, that'll cancel. I do to the other side. 24 divided by 8, y equals 3. Letter D, negative 15 equals 3x. Negative 15 equals 3 times x. It says 3 times, so I do the opposite operation. The opposite of times is divide. So we're multiplying. We're going to then, in case divide, 3 and 3 would cancel. X left all by itself. What I did to this side, I have to do to this side. So 15 divided by 3 should give me negative 5. There's my answer. In letter E, I've got 3/4 times y equals 11. Now again, here I have another fraction, and it's multiplication, so I'm thinking division. But instead of dividing by a fraction, I want to multiply by the reciprocal. Very good. I multiply by the reciprocal means I take 3/4 and I flip it. That's 4/3 now, and I multiply, which would allow the 4 and the 4 to cancel, the 3 and the 3 to cancel, and then y would be left all by itself. Now I multiply by 4/3 on this side, I have to multiply by 4/3 on this side, so I'm going to write this out, 4/3. Now if I would multiply this out, numerator times numerator, denominator times denominator, I'd look first to see if there's anything to cancel. If there's not, then I go ahead and multiply. 11 times 4 is 44, 1 times 3 is 3, and there's my answer as an improper fraction. Letter F, I've got 8 equals negative 5/12, n. Again, 5 and 12, 5 divided by 12 is multiplied by n. I could divide by 5/12, or I could multiply by the reciprocal. Now the reciprocal of 5/12 is 12/5. Those two things would cancel. 12 and 12 would cancel, 5 and 5 would cancel, and I would get n. Now if I cancel with the negatives, it's going to get rid of that negative and turn this into a positive. I'll keep that negative when I'm doing that to the other side. So what I did to one side, I do to the other side as well. So here I would have 8 multiplied by negative 12 divided by 5. Set that up so that it's numerator over numerator, denominator over denominator, and now I can do the math. I've got 8 times 12. 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. That's 96/5, or 96 fifths, and that's a negative answer overall, equals n. So each time I'm solving with our inverse operations, I'm looking at what operation is there first and then doing the opposite. The only special case where it showed up was here where you're multiplying by a fraction, here where you're multiplying by a fraction, and here where you're multiplying by a fraction. Instead of dividing by a fraction, you multiply by a reciprocal. Now the last problem is our word problem, the application of what this looks like. And let's just read through it together. It says a rectangular pool has an area of 140 square feet. If the length of the pool is 16 feet, what is the width? Well, the pool, since it's a rectangle, let's draw that rectangle out so you can see our thinking. It says that the rectangular pool has an area of 140 feet squared. That means the length times the width. This would be the length and this would be the width. If you multiply those two, you get 140. But it gives us one more piece of information. It says the length of the pool is 16 feet. So we know that this equals 16 on this side. We don't know what the width is, but we already know the equation. 16, which is the length, times the width equals 140 feet squared. Well, how do I find that missing variable? looks like one of the one-step equations that we just looked at. In this case, I've got 16 times w, that's multiplication. I do the inverse operation. So instead of multiplying by 16, I would divide by 16. If I divide by 16 on one side, that'll cancel. I divide by 16 on the other side. 140 divided by 16. How many times does 16 go into 140? 8 times for sure. 16 times 8. 8 times 6 is 48. Carry the 4. 8 times 1 is 8 plus 2 is 128. 128 minus here is 12. 16 goes into 120. Let's see, 5, 6, 7 times, 8.7. 16 times 7. 7 times 6 is 42. Carry the 4. 7 times 1 is 7 plus 4 is 112. It's going to be an 8. Bring that down. A 0. 16 goes into 85 times. 8.75. My width here is 8.75. If you wanted to check, you'd say 16 times 8.75. You'd figure that to be 140. So the word problem itself allows us to set up this equation. Then the equation shows up as a one-step problem in which I do the inverse operation. When you do that inverse operation, make sure you do that to both sides to get that variable all by itself, and you can simplify and solve. Hope that helps you with your homework assignment. God's blessings.